Hi, this is Mr. Merrill, and in this video we're going to talk a little bit more about these motion diagrams and try to get at some of the trouble students have with them. So first we're going to talk about how we can find the velocity off these motion diagrams. So first of all, what we have here is two objects, A and B. Remember, this axis is not a time axis, this is a position axis. And these little arrows here are not just arrows, they're velocity vectors. So really we could come in here and say something like that above each one of these arrows. So to find the velocity of A, we first have to understand what velocity is in terms of constant velocity motion. A constant velocity motion means that it's going to cover the same distance for the same time interval. So let's think about how much distance it's going to cover in each one of the time intervals. So each dot is separated by an interval of time of 2 seconds. So we go over here and we look at, say, this dot here. We say this is at 10 meters. And we should recognize that this must be the initial position of A if it's traveling in this direction. So the next dot over we can estimate here is at about 2.5 meters. And because it's the preceding dot, it must be at 2 seconds. So what that means is it covered 7.5 meters in 2 seconds. So it must have been traveling at a speed of 3.75 meters per second. The only other piece we have to add to that to find the velocity is recognizing the fact that this motion is happening in what we've defined to be the negative direction, which almost always is to the left. So the velocity of A is negative 3.75 meters per second. If we want to do the same thing with B, we come over here, and we don't have to use the initial point, we can use any point, but we recognize that this must be the initial point of B. It's located at negative 20 meters. This dot must have been recorded at 0 seconds, and the next position is recorded at negative 10 meters, and must have been recorded at 2 seconds. So what does that mean? It means that B traveled 10 meters in the positive direction, and it did so in 2 seconds. So a quick calculation, 10 meters, 2 seconds. We can find that the velocity of B is positive, because velocity is a vector, meters per second. Okay, so with a little bit of practice, that's not too difficult. The next two questions can be tricky if you don't understand what the motion diagram is saying. So what time do the two objects cross? So what I'm going to do first is just go ahead and label the times for each one of these. So the third dot here is 4 seconds, the fourth dot here is 6 seconds. At what time, to find the red, I say that's 4 seconds, and this is 6 seconds. So this is how we have to understand this. The A is starting over here at 0 seconds. B is starting over here. Okay. 2 seconds later, we find B is here and A is here. They haven't crossed yet, right? They're still facing each other. But in the next time interval, at 4 seconds, we see that A must have crossed B. Because now at this time interval, at 4 seconds, they're no longer in front of each other. Now that doesn't mean that they crossed at 4 seconds. That wouldn't make any sense. They're not at the same position. And it doesn't mean that they crossed at 2 seconds. That doesn't make any sense. They're not at the same position. What it's trying to say is somewhere between 2 and 4 seconds, somewhere between these two dots being recorded, they must have crossed paths. They must have had the same position. So based on just this quick information below, we know that they cross somewhere between 2 and 4 seconds. We could find out more exactly, and I might do that at the end of the video, but for now, our purposes, just knowing that they cross somewhere between 2 and 4 seconds is good enough. On that same note, at what position do the two objects cross? Well, if they were here at 2 seconds, and then they were here at 4 seconds, we can get some idea of where this crossing happened. Well, it couldn't have happened anywhere to the right of 0 meters, because B was at 0 meters at 4 seconds, and we know the crossing happened somewhere between these two times. And it couldn't have happened anywhere to the left of -5 meters, because A was there at 4 seconds. So by narrowing out those two possibilities, we're left with a small region where the crossing could have occurred. So we know for sure that the crossing happened between -5 meters and 0 meters. So this gives us a range of times that the crossing occurred. This gives us a range of positions. Very quickly, what's a majority of people who are not comfortable with motion diagrams going to say? If we go back and kind of get rid of all this stuff and just look at the initial problem, if we look at what question 4 is asking, at what position do the two objects cross, someone who's not comfortable with motion diagrams, I guarantee you is going to say they cross at 10 meters. Because visually that's what looks like what's going to happen. Until you put the time intervals above it, 0, 2, 4, 6, that type of stuff, it's not going to be obvious that the crossing had to occur somewhere between -5 and 0 meters. So for our purposes for the quiz, you could go ahead and walk away with this. I'm going to go ahead and finish up this video showing you how, if you wanted to, you could find specifically, not just a range of times, but specifically these times. So this requires a little bit more algebra, that's why we're kind of skipping it, but if you want to know. So for A, we could actually set up an algebraic model for A, because we know the initial position, and we know the velocity. So -3.75 meters per second, and it had an initial position of 10 meters. We could also set up an algebraic model for B. So the reason we skip this algebra in class and why it won't appear on the quiz is because it's dealing with a system of equations, and even though you've covered in Algebra 2, you're probably not yet comfortable enough to deal with it in the context of physics. But we can use this type of concept to do questions like 3 and 4. This gives us a range. We better make sure our answer falls within between these ranges. So if it asks, at what time do the two position objects cross? Well, we know for sure that when the objects cross, they had the same position. That this current position for A had to be the same current position for B when the crossing happens. So we could say that at this one particular time, this x for A is this x for B. So we could set these two equations equal to each other, -3.75. Oh, a little mistake here. This should be negative. $20. Not paying attention. So we could set these two equations equal to each other. This is a t. And do a little bit of algebra to solve for t. So I could go ahead and add this to that side, add this to this side. Divide both sides by 8.75, and we better expect our answer to be between 2 2 and 4 seconds. And if you do 30 divided by 8.75, you get an answer of t having to equal 3.43 seconds approximately. Okay, and that does fall within our range. With that same idea in mind, how do we find the position exactly? Well, now that you know that the crossing occurs, you could go back and substitute this time into either equation, meaning I could plug it into here or here. You'll get an identical answer. And find the exact position. So I'll use B's equation because it's a little prettier without the decimal. 5 times 3.43 seconds minus 20 meters. Just plug that in your calculator. And you could find the exact position, and lo and behold, it is between -5 meters and 0 meters. We get the exact position of -2.85. So you don't have to worry about finding these exactly for the quiz. You really just need to know how to do this type of thing. We'll begin doing more of this mathy side of physics once you get a little more comfortable with the algebra too. So hopefully that helps, and email me if you have any questions.